Right, let's carry on with this transformer worksheet. So what did we say about this? You've got your iron core, soft iron core. You've got your primary coil, which has a voltage V primary on it. And the number of turns on this coil is called the NP, number of turns on the primary coil. And then on the other side, the output. So this is the input side, this is the output side. You have the number of turns on the secondary coil, and you have the voltage across the secondary coil. If there is less turns on the primary coil, right, if there's less turns on this primary side compared to the secondary side, then it is called a step up transformer. So the voltage here will be higher. So you've stepped up the voltage. If you had it the other way, if you had more turns here and less here, it would be a step down transformer. Right, let's keep going. Right, let's have a look. Right, let's go. You've got an electrical plug, you've got a socket, you've got a switch, and containing a step down transformer. If it's step down, let me go through that again. So look, here's my soft iron core. The reason I'm drawing it so I can internalize it as well. So I've got, just say 1, 2, 3, 4, 3, 4 on here. So remember we said this is voltage primary and number of turns primary. Now on the outside is step down, so I'm going to do only 1, 2. So this is the voltage secondary, number of turns secondary. So because there's more turns here and less here, it's a step down. It's a step down. Right. Compare the number of turns of the primary of a step down. There are more turns on the primary coil. That's it. Simple. Right, this transformer is designed to reduce the voltage from, okay, so what they're saying from, so that's your primary voltage, and this here is your secondary voltage. Ooh. So they have got a current formula, right? So they're saying that the secondary, so current is I, so secondary current. So we want an equation linking primary voltage, primary current, secondary voltage, secondary current, right? So we've got to learn this then. So V primary times, yeah, voltage times current on the primary equals voltage on the secondary times current on the secondary. We need to write that down. Emergency. It's good to know this, so then you know that they exist. And if you know they exist, it's a good thing. So voltage primary times current primary equals voltage secondary times current secondary. You'll be given these, but like I said, if you got them in memory, it's easy to go to them. That's your next level clever. Bare clever person. If you are, then you should be teaching me, mate. Right. Yeah, that's it, we've got it. We've done it there. Right, calculate the primary current. So we're assuming it's 100% efficient. There's no loss of thermal energy or electrical energy or any energy. So we know, we said V primary, I primary equals V secondary, I secondary. So 230 down to, can't remember them, 5.5. 5.5. So we're trying to work this one out, and we've been given I secondary. It's 1 amp. That's step one. Then, well, it's only 2 marks, but it doesn't matter. Then we want I, P. We're just going to get into the, did I just do that? Excuse me. VMOS destroys this. That was what? Hello. That was 1. Right. So 5.5 times 1 divided by 230. So IP for us should equal 0.024 amps. 0.024 amps. So if you put this into the calculator. So our habit is write the formula, substitute, rearrange, substitute, then give your answer. I know it's only a 2 marker, but that's our habit, because we don't lose any sort of method marks or working out marks. Yeah. Right. A student noticed that electrical appliance flow becomes warm. Suggests how this will affect the input to the transformer. Secondary voltage and secondary current do not change. Right. When you see warm, you're talking about heat. You're talking about when heat goes up in a wire, resistance goes up. So it becomes less efficient. Right. What they're saying here is the output doesn't change, so then the input needs to change to keep that the same. So the input power has to increase. The input voltage remains the same. The input voltage remains the same. The number of turns remains the same. That doesn't change. So the current has to increase. Right, how can we say this? Look, you've got 2 options. You can either learn it that way, or you can say, look, we know the number of turns doesn't change, so the voltage on the primary stays the same. So the number of turns doesn't change. We know that. That's a physical thing. The voltage will not change. So the only thing, because power equals current times voltage, if the power's gone up and the voltage is stayed the same, the current has to increase for this equation to be equal. So what they're saying is the current has to increase because you're losing energy through heat, because it becomes warm. I'm waffling a bit. I am officially a waffler. Right. We'll was there anything else that we needed to do here? Yeah, we've got here. That's it. We'll call it quits there.